Perfect. So today we are going to continue in the Bash in the Bash environment, going from a new part of a new integrated programming language that is directly linked inside to the Bash environment, that is the so-called AWK. But before to go deep inside to this part of the syllabus, let's have a look of the command that we have done in the previous one. And I want to emphasize a bit more about in particular about when we define a variable inside to the Bash terminal. So every time a variable will be defined always. So let's use the same variable that we were doing last time, here equal to 2006, okay? So pay attention never to put space, okay? So never to put space here or here, because actually sometimes you will not neither get an error, okay? So whenever this is one of the few cases that in Bash that whenever you define between the variable and the variable name and the value of the variable, never put a space. Also, let's suppose that you want to do months in here. Let's say January 2006, do it like this and not with a space, okay? Because whenever you enter a space, you know, this command is over. So it's starting a new command. That's why now we can say 2006, command not found, okay? So there are also ways to deal with this kind of variable that have a space in the middle, that in particular is, you know, is identify this one as a string. Actually, neither like this with the two quotation. But again, it's much easier do not dealing with the space, not inserting the space, than not having a space and every time dealing with the space, you know. Also, for example, today with Rosie, especially Mac user, they quite often they have, you know, okay, let's do Rosie. It was having a folder name like this, then space data. Having a folder name like this is a nightmare, okay? Because it's getting complex due to there is the space and also the single quotation. So always try to simplify as much as possible your file name, folder name, and in the beginning, if you get a folder name that is very rare, I mean, it's very particular, like the one that I was mentioned before, is allowed to change even in over here, you know, over here you do right click and then you can do rename, okay? Because even sometimes to change that one is quite complex inside to the Bash environment. Then you get used, but in the beginning just renaming by the graphical user interface, and then slowly you will learn how to do it also to deal with this kind of variable. But quite often I just change in the beginning as soon as I get it, and I don't use it anymore space. You feel free to use capital letter, okay? For identify, so make dir my data, or, you know, a folder with the underscore. So this is also very typical to insert a space. So as a file name, but also inside to the file sometimes. So inside to the file, if you have word that have a space in the middle, then you have to treat it in some way. So sometimes it's much easier to not insert any space, and you can insert uppercase to distinguish the two words, okay? So whenever you recall a variable, we say 2006, okay? In Bash environment, to call a variable, you have to do echo $year, okay? The $year is a double meaning variable, so pay attention, because today we will see another meaning inside to the WK, okay? So whenever you have the $sign, always be careful about the situation, because you can have different meaning. And whenever you print it, you need to print it, you need to recall this variable, you have to insert the dollar in front, okay? Sometimes, you know, especially if you need to let's suppose, let me see if I have a file. I have a file here. Okay, another folder very useful to work is the TMP. TMP is a folder that every time that you shut it down is going to be cleaned. So very often, developer enter in TMP to make test, because they don't have to worry to remove the data. Every time that we shut down the computer, TMP will be cleaned, okay? So it's very common to see people entering in TMP, make some tests and so on, okay? So let's suppose that I have a file that is, you can create a file, an empty file with a touch. And you can say here, okay, to here, I can create this file here. Okay, so my year is going to be, my file is going to be with the word year and then the variable of the year. So in other words, it's going to be now, it's going to be, if I see, it's going to be year 2006. Okay, perfect. Let's suppose that we want to add in some information, some other, another string after the year. So for example, we want to add in year sampling, okay, 2006 sample, okay. So now, if you use it as it is, let's see what it's getting. It's going to create year without anything. Why? Because it's reading all this one as a variable. But this one, we don't have it as a variable. We have only this as a variable. So we need to we need to identify to the bash environment that our variable is just this one, and this one is nothing else than the string. Okay, so in this case, we can, let me repeat this one, we can insert the curly brackets, okay, to identify that this is a variable. Okay, and then is the string that you want to add. At this point, you can see that now I have 3 files. I have 3 files that start with year. I have the year, the mistake that I created, the one that I create without, just with the variable, and the third one, the file that is 2006 plus a certain string. Okay, so these curly brackets identify that this one is real a variable. Okay, so something similar, you can do it, but you don't need to specify. You can do both. When you inserted the dot txt, for example, he identify immediately that this one is not a variable. Okay, is not part of the variable. So indeed, you can use it as it is, and you have the txt. Okay, you have here the txt, or you can do it also without. Okay, you can see now is the same. This one and this one is the same. Because with the dot, you don't really need it. But again, if you put it, if you want to always put it, feel free to do it. Okay, it's not a mistake. But of course, when you're coding, if you don't need it, you don't insert it for a matter of time. Okay. Okay, so these one are the most tricky one inside to the Bash language, and then are very useful for the for loop. And we will see different application, okay, of the for loop. Quite often, I always say, try first one line, a single command for doing a for loop. Try first a command by itself, and then try to build up a loop for creating the full story. For example, now we are working with this touch, and we create this file. As you can see, they are empty. You know, 0 means no line, they're completely empty. are empty file. Okay, 0 is this one identify how many bytes. So now that we know, for example, that touch, okay, 2000 year 2000x is creating one file. So now let's build up a loop for 3 years. 4 year in 2000, 2003, 2001 to 2002. Do semicolon, do touch, and we repeat perfect the same, okay, and then in the end semicolon again, done. Okay, this is how you build up in one line. And make a mistake, look over here, look, this is one cases. Let's see this, I don't know if you see the mistake, but let's see. Now I'm going to say, okay, let me see how many files I have with here. I should have 1, 2, 3 files. Okay. I'm missing this one and this one. Anyone can spot why? There is there is no, this is a case that I make the mistake, but without warning. I mean, there is an error.
There's the first year is it has a typo.
Yeah,
no?
Perfect. Yes, this is the typo. And be careful about this, because this is one of the cases that is not giving you any error. It's not a syntax error, okay? So now if I listed and I do year, then you can see that it's creating 2000, 2001, 2002. Okay? So the same operation, of course, can be done rather than type this one. You can type a command that is building up this string, okay? So for example, sequence is giving to you the same from 2000, 2002, okay, is bringing these 3 years, 3 value. Is a sequence and the default is just increasing by 1. So now we can modify this for loop in some way that is using the output of this one is going to be used inside as a string. And be careful about this, because this one you need to identify by the 2 parentheses and then the sequence inside, okay? Sequence from 2000 to 2002, okay? So this one is one command that is going to be brackets to be as an input inside for the for loop, okay? Oops, for the for loop. This point I can, I can enter and I can see I can enter and I can do the for loop. Of course, it's not going, you don't see the result of this because it's going to be printed inside the for loop and use it immediately as a string. Okay, so this is very common, because quite often you do it a sequence of number for day counting, or so it's this one I use it quite a lot. Okay, then there are also some other. There was in the example also the use of, year from year starting from 2000, ending in from 2000, ending in 2002, and then this one year plus plus. Okay, this one, it was another syntax to do the same. And the year plus plus means increment by 1. But frankly speaking, I don't use it, this one, because it's too long to write, I just use this one quite often, sequence. Okay, and if you want to jump every 2 number, it's a bit different from R. I think you put here. No, you put here in the middle. Yeah. So rather in R, you put in the end. Okay. So you want to 2000, 2010 jumping by 2. Okay. So quite often, I very rare that I use this one, because this is much easier and fast and more immediately and so on. Okay. So try to get familiar with this for loop, because you are going to use it quite a lot, even if later on you are using Python for the manipulation, but we will see some application that you have many files, okay? So having the ability to directly work with this file with Bash is quite handy for this kind of, you know, the, first data manipulation, I would say, or data cleaning, or yeah. So I use it quite a lot for this contest, okay? Anyone was want to share what he was doing with his file? Maybe Martin, you want to say something? Which kind of testing you were doing? You want
Sure,
to
I can show you. Yeah, yeah.
Perfect. Yeah, you can show to everyone. Stop sharing.
Hope this works. All right.
Yeah,
Do you
can
see a Jupyter Notebook?
Yeah.
Yes. So yeah, I just have this one file that's from an old project. It's just called crop rotations. It has a bunch of data on farm yields. It's not really important. The only thing that I really did was it has this one column here. Where is it? Year harvest. It's the year of the harvest. So I was just grabbing for this essentially, comma, then a year, and then a comma again. So at first I was just redoing what we did in class, like counting lines that have, in this case, winter wheat, what kind of crop they had, right? I was just counting these lines for a bunch of different ideas. Then I was playing around with for loops and sequences, and maybe here the more interesting stuff starts. Actually, I have a question about this. So what I wanted to do, I mean, I achieved it, was to go into my crop rotation CSV and count how many lines each year has, and then sort it and print it out. And so
Okay.
all of this part here, this for loop, is just counting the number of lines.
Okay.
And then I used paste to paste together the sequence from 2000 to 2022 and this counting, and then I pipe this into the sorting, so I get something like this. But I had to use these, I'm not quite sure what they're called, but like make these variables, and it doesn't work on all Linux machines, I've learned. So I was wondering if there's a more elegant way to pipe this directly into paste, but I couldn't figure it out.
Okay, yes, it's correct. It's correct. It's quite complex to read.
Yes.
But is working. So in other word, the paste command we say the other time is pasting like this. Okay, it's pasting like this. So in the first case, Martin was using sequence from 2000 to 2022 to create the first column. Okay, and then he was using the second column was the for loop. Probably. Okay, first of all, the grep -n is giving to you already how many observations you have, first of all. Okay, if you do grep and -n, or -n or -c, one of the two, maybe it's C for count, and then you put one word.
Like, comma 2002?
Yeah.
Like this?
Yeah, perfect. So run it. So in particular, look, the 44 should be, I think, yeah, that one is giving to you how many line is giving. And be careful because there is the -n and the -c. N, I think, is giving the number of in which line is present that word. And the C is the count, if I remember correctly. So you need to check. Yeah, so this is the count, 319, okay? But be careful that now 2002 you should have the same.
No, I have a different actually. It could be that in this file there's another 2002 showing up, right?
Perfect,
so
perfect. Yeah,
that's probably
it.
But
this is a good example of how to combine different command inside to the the result, in this case, the result of sequence 2022 become an input for the paste command, okay? Then the same for the for loop. Okay. So probably that loop can be even shorter by using this grep -c.
Yes.
So you can skip it, but
And also
it's all
making
right.
this a variable and then using the variable in here is probably also nicer, right? Because this is just a copy paste, but I didn't know how to do that yet. So that's why I didn't.
Yes, perfect. So be careful that in this way, okay, it's perfect, you know. You achieve your result. The file is small, nothing critical, but you are reading the file 22 times. Okay, you're
Yes.
reading the file 22 times.
Yes, that's true.
So of course, is a small file is more than perfect. Okay, so but always keep in mind that if the file become big, you have to find a way to identify a faster way to read in only one times, at least less times. Okay.
So would I like first write the like an R? I would write the crop rotation CSV into a variable and then use grep on that variable, right? So not reading it in every loop.
No, because you can do a full file. No, it's not like you cannot have a full file as a variable.
Okay.
Okay. So for example, another option will be that in grep you can put different word as a pattern. Okay, so with the -e you can insert more than one word. So if you have -e and then you put another one there, 2000 -e again, 2003.
Do I need a space there or no?
E again.
E, sorry. And then
yeah, and then 2003. Yeah. And also at this point that you have this comma, I would over there put quotation, double quotation before and after the comma. Perfect. Yeah. Because over there you want to be sure that that one is really making a pattern. Okay. So this one is given to you already too. Okay.
Is there, so let's say now I want to count the lines. Is there an inherent order where I have to put the C? Could I put it
Yeah, okay.
here
This one you
or?
need to test. I don't know.
Okay.
This one
But there is an order. One has to do it right.
Yeah, now I don't know if I think it's giving you the
Works
total.
both ways.
It's giving you the total of
Of
2002
both.
and 2003. Maybe try to put twice, but I don't think so. So sometimes, yeah, it's a matter of taste how you can
Something like this.
manipulate. Yeah, you can try, but no, it's giving the same. So it's giving to you. But anyway, this is really nice example. Okay.
Yeah, and then it's just more of this. Now I'm just piping it into writing it into text files, essentially what we did just now. Oh yeah, then I got these errors because there is no 2000 or it only is from 2002 to 2020. So it does this perfectly fine, but then Python complains. So I thought this is a perfect opportunity to where is it? Yeah, so here I do it with manually to test whether my theory was correct. Okay. And then, oh, I did it somewhere.
Yeah, you do an if condition.
Yes, that's what I was looking for. Yeah.
Perfect. So that's
so I did with an if condition. Yeah.
Okay. Can you comment it also what is this time?
Sorry?
What is this command time?
Yeah, what is this command time?
Yeah, so it's giving it's down. So it's giving, go down. Perfect. So it's giving to you the time that is counting for doing the process. And you can see down in this pinky line is okay, it's so fast as though it's 0 everywhere. Okay. Yeah. But as soon you become bigger than a millisecond, then you will start to see the number increasing over here. So that one, the word time is quite often used. I think in R there is also system time or something like this. It's quite often used to compare between two processes, okay, yes. To one more process, okay, to see which one is faster and so on, okay. Okay, perfect. So yeah. Very well.
Yeah, this just puts everything together and then writing the files now without a Python error.
Okay, cool. Yeah. So this is the kind of exercise that you have to do it with with your data, okay? So Rosie, try to do it, and everybody try to do it with any kind of TXT file that you are doing. And also now you will see more example, more data handling that you can do with a TXT file, okay? Okay, perfect. Somebody else want to share? So you can stop, want to share the screen and asking some question about, I was trying to do this, I didn't succeed. So pay attention that this part of every lecture is very important to reduce your frustration if something doesn't work. Okay. Perfect. So let's go directly inside to the topics of today. So I'm sharing the screen. Okay. So today, if you go inside to the syllabus, you will see that lecture 3. So I pasted the suggestion assignment from last times. So it's whatever we were talking, copy moving file and so on, unzip it, also using the apt-get upgrade for the installation and so on. So today we are going to discovering the power of AWK. So AWK language, probably most of you never heard about it, but it's very old programming language that, even if it's still very old, is one of the fastest for processing text file. That's why I keep using, even knowing Python and R. And the AWK is coming from the developer Alfred Ode, Peter Weinberg, and Brian Kernighan. So they are the acronyms, the initial of these 3 developers, that the 77, and these are the father of the C language, okay? And it was building up for text manipulation, okay? So in few words, whatever you can do with Excel, you can do with the AWK, just to give a similarity. So what do you do in Excel? You do row multiplication, column operation, multiplication between columns, sorting, string manipulation. So all this kind of operation that you do in Excel, you can do directly in AWK. Is directly implemented in the Bash language, okay? So every time, so just giving you, so every time that you enter inside Python, again, every time that you need a Python 3, you enter inside Python. Over here, you are in a new environment, okay? So this is the difference. You are in the new environment, and immediately you enter inside to the RAM of the computer, okay? And the same is for R. So if you quit, exit, you can do Control D, and the same for R. Okay, over here you also are in a new environment. So the difference is that with the AW, so if you type a command, print WD, print working directory, is not going to recognize, because you are completely in a new environment. Okay, rather, so now I have to exit Q. Rather, if you enter inside WK, is directly embedded inside to the Bash language. Okay, so you can really manipulate in a really efficient way all these text file together with the Bash command. Okay, so you can click immediately over here in the syllabus. You go directly in this file. Okay, so let's see before. Let's see the syntax of AWK, and then we explain how it works. Okay, so for giving you an example, a clear example, build up this table. So let's suppose that we have this table as our TXT file. Okay, so there are mainly 3 parts in AWK. So first of all, you identify AWK. You have, so this is always the case. You have AWK, the starting of the command, then you have single quotation that is going to be closed over here, input, and then whatever is coming out from the input, the output is going to be saved in a new file. Okay. Inside to the AWK string, we can have 3 actions. And pay attention to this one, because if you remember, then it will be fine in building up. You have a pattern between square brackets, and if you remember, the square brackets identify something that is can be there or cannot be there. Okay, is an option. Then you have an action, and then another pattern. Okay, in particular, if you jump down over here, you can see that the pattern is done before to read the file. That's why you have the word beginning. So before to read, do something. Then the action during the reading of the file, and then another action in the end of the file. So if you want to put in words, is going to be read in this way. Beginning, do an action, do something before reading the input txt file, so the table. Then the second one, the intermediate, the action, do something during the reading of the input txt file. And then in the end, do something in the end of the input txt file. So in other words, do something here, do something during the reading, and do something over here. Okay. So this kind of thinking allow you to really have massive operation in the txt file that can be extremely huge. Okay. So if you want, we can you can open directly this Jupyter notebook. I think for me and for showing you, I think it's easier if I copy paste over here. Let me try and see if I can. But feel free to open the Jupyter notebook. There are very few commands, okay? So you can even types. If you do it in the same way, you can even type, and in this way you get familiar also with a string, and yes, so yeah, with shortcuts and so on. So as usually, we are going to use the file like before. Okay, so just to remind you, it was a small file with the 5 columns. Okay, so this is our file. So this is our input txt file that we are going to manipulate. Okay, so there are also for AWK, there are some variables that are, or some option inside the AWK that are already predefined. You don't need to define, okay? So in particular, this one was the case of AWK print. So AWK print $2, $5, okay? $2 is the second column, and if I want to put $5, I can put only $5, the 5th column. And be careful about this, that if I want to put both, I have to insert the comma. Be careful, because the comma here identify the space. It's not identify the comma. So indeed, I have column 2, column 5, and then the space over here. Okay. So pay attention that this one is an already build variable. Why I call it variable? What the dollar identify in Bash is identify something that is changing. Perfect. Okay. So why this? Because AWK is printing column 2, but actually is printing row 1 of column 2, row 2 of column 2, row 3 of column 2. That's why is dollar, because it's something that you change in cascade mode. And that's why AWK is not, it will never fill it up the RAM. It's going to be always faster than any R and Python code, okay? Because, because all the RAM is used to just process one line. Then it's going to the second one. Then it's going to the third one, okay? So it's working cascade mode. Always remember this, that AWK is working cascade mode. And that's why you have the dollar here, because it's something that is changing continuously, going down. Okay, is it clear? The concept, anyone? So rather when you do, when you do it in R or in Python, you identify a variable that is already inside to the RAM, or all the file is already inside to the RAM. Over here, no, the file is still sitting over here. And whenever you say print $2, is printing the first number, then is done, then is printing the second one, then the third one, fourth one, and so on and so on. And that's why it's $1, because it's something that is changing. And the same for column number 5th. So be careful about this, that of course, whenever is printing this one, okay, let's do it here, that different. Whenever it's printing this one is gone, so he doesn't know anymore in the RAM, okay? So you have to think, if you have to do something fancy, you have to keep in mind this kind of iteration to do this kind of behavior to code, to building up complex code. Okay, now, when I started 20 years ago, AWK was extremely fundamental because, for a simple reason, because the RAM was very small, okay? So whenever you were going to open R, or, okay, Python was not there, R, you could not really handling many columns and row. Okay, now it's much better, okay? But, so, and I was writing like 20 lines of AWK to do a standard deviation in a column, okay? Now, you don't need to write any more 20 lines because you have R and Python that does it in one line. But knowing about printing column 2 and column 5 and reduce your file, because maybe you just need these 2 files inside Python, then you can do, you can do the sum, you can do the standard deviation inside Python, but at least you enter only with 2 columns. That's one is the beauty of, and you don't need to know many AWK command to build up again 20 lines of AWK. It's enough really one line that squeezing the data as you want, and that's it. And this is then you enter inside to the to other command. So let's see also something else, some other variable that are already built, like number of field. Again, an F is, remember, this one is easy, number of field. Okay, and F, let's see what is given to you. Of course, I can also write in this way, then put the file, print. Because there is this, okay. Okay, so over here, I was print number of field is giving to me how many field they were in this row. Okay, you remember the input? You remember the input that was 5 field in each row. So it's going to give me how many field in each row. And for example, this is extremely useful in a huge file to see, are all my column there? Is everything number 5? Okay, so for example, what I can do it, I can say, okay, without printing 2 and 5, so I give now, are all of them is printing number 5. What they can do, there is one nice command that that, okay, is called sort, is going to sorting. Okay, now you will not see but let's go directly over here. You do unique. Unique is going to give you, how many unique file you have among these files that are 5 everywhere. Of course, now it's giving to you one file unique because you have, you have everywhere is 5. But as soon you have one row without, then you will have, actually, you know what? Let me do it right now. We have the input txt that we were using the other time, I think. Input, yes, let's use in this one. txt. So it's the same file, but let's enter in this file. I can enter with Emacs with the command dash and \v, I can enter here and I can modify. So let's remove a few lines here and here. And here we remove even more. I save it and then I close. So now my file is much smaller. Okay, smaller. It has missing column. Let's rerun that command. Print number 5 in txt, input txt. Okay, so it's going to print everywhere 5, but in the beginning, so we can see with more, it's going to be 4 and over here 2. Okay, so now what I can do I can do sort. Okay, because I need first to sort and then I can do unique. Okay, so it's given to me, be careful because there are few, I don't know how many, 2 and 4, yeah, few rows that have 2 number of field and few rows that have 4 number of field. At this point, I can even say -c is given to me how many rows I have with 2 field, yeah, and how many rows with 4 field and how many rows with 5. That is the correct one. So this one, look, is already you should have a for loop like the one that Martin was building, very similar, and you are going to read the file the file several times. With this one, you are only once done. That's it. Okay, so this is the beauty of combining, for example, the AWK with sort and unique. Be careful about unique because it's making the collapsing of the column, but consider the sort. So if you don't do it, this, okay, now I think you will, yes, look, it's going to, if you don't do the sorting first, it's going to collapsing, but then starting to collapse again if you find something different, okay? That's why I was sorting before, okay? But both of them, the sorting I was mentioned, that is extremely fast because it's already been optimized very well in a parallel process. So, okay, now the file is extremely small, but even it will be big, it will be faster than anyone else, okay? So this is the kind of data exploration that you can do. The same, for example, with NR, NR is number of row. You can do immediately $1, $2. So this is, for example, is very common in our field. You work somebody that work in data manipulation. Number of row is given to you, is bringing to you the row ID. Okay, so is putting immediately an ID in each single row. Very, very useful when you want to have a unique database, in a database, an index, the so-called index ID. Okay, so this is how you combine in an efficient way. And also in this case, you remember last time I was creating 2 files here. Okay, you have these 2 files. So also in this case, AWK is able to work with the 2 files. So actually in particular, if I put 1 and 2, okay, so over here I'm working with these 2 files, is given to me for the both file. Okay, and now you can see that here is 2000, each file of these was 1000. WC dash L. Yeah, okay. So you can see that each one is 2 lines, 1000. So by this, I'm operating already in 2 files. Okay, so rather than building up a for loop that say, okay, for file count me, print number of row, is already combining the 2 files. And the same I can do perfect the same with the previous command, with the number of field, with the unique. I can use the input txt file, is going to give me, is going to count me. Okay, it's going to count me all the number of field in the different file, not in only one. Okay, so it's very, very similar to what we did last time. So this is the beauty of AWK. Okay, so many of the operations that Martin, for example, was doing with the grep can be even combined. You know, you can have also a grep function inside grep, meaning search for a pattern inside AWK. But of course, if there is grep, that is much easier to use it. Just use grep, you know, because you would. But for example, let's okay, the if conditions are below. So let's follow this one. So you can have a combination of command, as you can already see, that now this one is an output of AWK, but in reality, I'm piping inside a bash command. Okay, so this is the beauty of having AWK directly built inside bash, because you can combine with bash command. So let's see this command at this pattern, because now whatever we were doing by reading the file. So in a cascade mode, like I was mentioned before, every time that you do AWK, the central operation that most of the time is the one that you use more, is done in cascade mode. Anyone can stop. Yeah. In cascade mode. So it's quite obvious to do an operation row by row in cascade mode. But sometimes you always need to use it also, this other pattern, beginning and in the end. Okay, so let's see how to use these two. Okay, so for example, if I want to, I keep using, it's the same. I keep using this file because it's perfectly the same. TXT. If I do it this one, this full line, I can do okay. So here is doing okay. Before to read the file, print the word sum before to read the file. Okay. Then during the reading of the file, let me make it bigger. This way you can see. No. Okay. Okay, now it's easier to see for you guys. So before, this one is the first operation, before to reading the file, this one, print the word sum, just a word, okay? Then this one is the operation that I'm going to do it. So in particular, I identify a variable, and this variable is going to be sum to $5. The sum is this one, is going to be adding, let's say word adding to $5, and $5 is my column. Then I have another operation that is going to print. Let's see first the result, and then we explain even better. So if I'm printing, you can see, and just to remind that $5 was my column with the head, with the Barnett area. Okay, so now what I'm doing, when it's reading the file, sum is equal to 0 because it's in the beginning is not defined. Okay, and then I say, okay, reading the file. Over here there is nothing, so it's going to be not counted. Then in the second row is going to be 0.6. Then 0.6 become this one plus 65, and it's going to be 65.06, okay, and so on. So it's going to sum all common run. In the end, it's going to print, and now I'm explaining also this one, the total sum. So this is the way out, for example, to do in a very efficient way the sum of a column, okay? The sum of a column. So if I want the average, of course, the average is nothing else that the sum divided by the number of rows. Okay, so this is going to be my average, but pay attention, be careful, because over here, number of row is in this case that we remove the file over here is going to count also this. Okay, it's going to count also this one in here because we manipulate this file. Okay, so of course, whenever you do it something, you need to be careful that is the right way to do it. So in this case, you should count how many these one are there and then divide to get the average. But anyway, just this one is just an example. So the printf, this is just printing, but in particular, the printf is giving the F stay for format. You can also use quite often, I use it and you will see even before, you will see me use it just print sum. Okay, print sum. But in this case, okay, by printing, before it was like this, I can show you this. You know, by print, you are getting some default of the format. In particular, is going to truncate after 1 decimal of floating point. Rather with this one, with the printf, and then again, F as type of format, you can specify the format that you want. And in particular, you can say the F is the F for floating format, floating, so with the dot, and the default is 6-digit, but you can also specify how many floating point you want, the precision, the so-called precision. And if I remember correctly, I always make a mistake here, should be here or the way around. Yes, 2, yeah. So you say 2 points, 2-digit after the dot. And the same if you want a string or you want the integer. If you put int, I think just I, if I remember correctly. Yes, so it's going to be to put just the integer, okay? So it's the format that you want, and this dash n is going to say, go to the other line. So over here is the other line that is happening over here. Okay, so here is identified that he has to go, is the line ending, okay? So usually these are the way how to use beginning and end. And the beginning, of course, is quite often used to adding an header in the, you know, in the file operation. There is no, is the only way that I use it. If I want to adding an header, I do beginning and I print something in the beginning. Then I do the operation reading the file, and then sometimes quite not often, I do some ending that can be the sum of the column, that can be the maximum value of the column. Yes, this kind of operation. Okay. So I give you a few minutes before to go to the other one, to keep practice a bit with this file or with the file that you have. Okay, whenever you want. Be careful. Let me see something that in this way also you guys can work. The default of AWK, we always say, is the space as the separation between column is the space. So be careful about this, because these files are very well structured. So if you can see over here, they're very well structured. Okay, I remove this row, but over here is very constant. Okay, and there are no space inside to the column. So for example, Martin was showing especially files that are coming with nomenclature of city, you know, address name, people name. Most of the time they can have space. Even the surname, you can have, yeah, Spanish people, they have 2 surnames, you know, so quite often you have a space. And in this case, the best way to operate with this file is the CSV, it is the comma separator. So if you have this kind of file that are really, let's call it messy, you can work with WK, but it's not easy. It's very time consuming because you have to consider all these differences. You can working with the CSV, by inserting an option that say -F, identify that is a comma separator, okay? So over here you can say, okay, it's a comma separator. So when I say $1 is going to be considered $1, that here is a comma, okay? But then, you know, but then be careful, because if you have space inside, they can be a bit messy. Or even, you know, if I have something missing here, if this one is completely missing, this one become column 2 in AWK, okay? So do it, use it, but be careful and do it when your file are very well structured and you don't have so many. If you have something in the end missing, it's okay. It's not a big deal to work. But if you're starting having missing data in the middle, then again, you can work, but be careful about what you are getting is the right, is the real what you need or not, okay? So again, I give you a bit of time to manipulate a bit and try coding and do whatever you want to use, this file or your file. Get familiar with the
May I
yeah.
ask a question?
Yes, please.
How do we decide when we are encountering a file? How do we decide in this circumstance that we use the AWK or we just try to form a bash code?
Okay,
two different approach, right?
Okay, so yes, so yeah, good question. So first of all, you have seen that you can combine bash and AWK. So let's say that AWK is able to work a bit more deep inside to the file, like selecting columns, okay? Rather with bash, you could not select in column, even when we were using grep. So if in this file, you know, you want to use grep and you say, okay, grep, we say the year 2007, but okay, maybe there is no 2007. Okay, let's do months, months 07, but the 07 was happening also not in the months column, but also here. Okay, so in this case, grep, okay, there is the tricks of inserting also the space, but let's suppose that even the space, the space after and before is not working fine. So let's see how we can deal with AWK. So we can say, okay, print, there are two ways. You can do, let's do a simple one, then I will explain. So you can do print, you know, $3, and you print all this line, $3, you print all this line, the month line, and then you say grep 07. Now you are sure that you are going to grep inside column number 3. Okay, so let's say with the bash command, you can do a light text manipulation. Rather with AWK, you can go a bit more deep in what you can do with Excel, you know?
Okay.
Yeah, you can even, you know, you can even insert in an if function directly over here, and you say print, yeah, if $3 is equal, be careful that the Boolean operation quite often is identified by two equal. We say 07, then print. When you say print, is going, sorry, 07, yeah, when it's going to be print without anything, is going to print the full line. Sorry, make a mistake. It's going to print the full row. So as you can see now is 07 everywhere in column number 3, and it's printing the full line. So if you don't specify anything, it's going to print everything. The same is just if you do $0. $0 is also the full line. Okay.
Thank you so much. Yeah.
Yeah. So this is a matter of, you know, get used to the learning what you can do with only with the bash and only with the WK. Always try to search, for example, I mean, the AWK has been used for 50 years, so the example are plenty, you know. So sometimes you find immediate, especially for something small, you know, that this is what I suggest to use it. Is very easy to find something already built that you can just copy paste and see. Okay.
Thank you.
Okay, cool. So yes, so please, I stop sharing. Get a few minutes, like 5 minutes, to work with the file, AWK, parentheses, and so on.
I'm sorry,
No,
may I ask?
also, sorry. Sorry, you go.
Yes, I would like that just ask a question because I have not any this input txt file in this shared directory. How to get this file just to this testing file just to
Perfect, Alex.
take
You can
out with
also,
this.
yeah, you can also use the. Let me share again. The file from the file is the same. I just shifted because it was easy for me. You can use this one. It's perfectly the same. It's just shorter. Can you see?
Okay.
Okay, it's the same. Okay. Anyway, be curious, and also, you know, in this txt file there are other files, so just pick up one. You know, any file is fine. There are actually there is also CSV, so if someone want to start to work with the CSV, can also do it. Yes, over here. But look, this yes, so this one can be a bit tricky because you have CSV. I mean, you have this comma separator, but you have also the space. So it can be not tricky, but is very well structured, this file, so should not be complex. Usually I always put data set that are easy to work with, okay? Okay, I'll give you the silence for a few minutes.
In a CSV file, it's very common that I have that my first line is a header. Is there a way to skip that if I want to calculate the sum or something like that?
Perfect, good point. Okay, if you want to calculate the sum, is not a big deal because
would it skip the characters or turns it into ASCII, or I'm not sure.
No, it's going to skip the character, but it's a good question, and you can do the if condition. If is number of row bigger than one. Okay, so I have it was a bit lower, but you can look, yeah, over here. So over here you see, for example, this is another way, another syntax that is quite often you find. I don't use so much this one. I prefer the if condition, that is a bit more easy to read, you know, but this is perfect the same. So is this one you can read in the same way. The logarithm of a letter is going to give an error in this case, but if you do this one, is going to do the logarithm. This is what, you know, logarithm of number or column number 5.
So
is to skip the header and number for row bigger than 1. Or you can do the same, and actually I prefer always this kind of if number of row bigger than 1 is the same, but quite often you find this way in internet because it's a bit shorter, but I prefer this one because it's more readable actually. Yeah, so in this way you skip the header quite often, very easy.
And why did we need the curly parentheses around NR larger than 1?
No, sorry, my mistake. Sorry.
Okay.
Yeah, good point.
And then in the first version, the shorter one, is the NR larger than 1 then a pattern?
No,
it's outside the. No, it is.
Yeah, is an if condition that you identify after the parentheses. Okay, outside to the parentheses. Okay.
I meant in the context of, so the AWK syntax is AWK apostrophe and then pattern. Is that a
No,
pattern?
in this, no.
Okay.
In this way, everything is the internal action. Okay. So over here you can, okay, this is the case. This is the, a combine, I mean, I want to say is
Like some
a
shortcut
case,
or
no, is a case that the number of row is the first line, but over here you can also say number of field equal to 3, you know, and if you were using the input txt that we were using, that the one was modified, maybe I don't have it. Number of 2, number of field equal to 2. Okay, it's giving infinite, so because it's that one. So let's go 4, and we do logarithm of 4. So it's going to use this one, but this one is not in the beginning, is in the middle.
Mhm.
Okay, so the number of field equal to 4 is not, one second, is not this part here, but is everything is the action. So everything is done during the reading of the file, even this one.
Okay. But the syntax is then a bit odd. I can see why you don't like it because it's outside the curly parentheses,
Yes,
right?
that's why I don't use it so much. I prefer always to having everything inside to the curly parents is a bit more, but it's quite often use it in Alps, in online example. So that's why I also put it an example over there. Okay. Okay, perfect. So try. Give you a bit of silence and
And I'm sorry, may I ask one more question? How could we refer to the columns of this data sets? Can we refer to them by their names, like, for example, by their titles, or only by their order, like 1, 2, 3, or so on?
Oh, okay. I would say yes, but that one is start to become a bit complex. Because pay attention that the AWK has an internal for loop that goes down. Okay, we say that it goes down in the cascade mode. But in this case, you have to build up a for loop that check the first line, if is equal to here again, here, then print. Okay, so that one is possible. I can even show you. But it start to become a bit complex, and there is a simple way to do it, you know, directly in R, in Python. So I can show you, maybe during the break, I can build up the line. But is that case that is becoming a bit longer to learn it than not to do it in another programming language. But good question, and I will show you how to do it.
Okay.
Okay. Okay, let's, in the meantime, you practice a bit, build up the line. Let's do a break. We come back to 30. Okay.
Okay.
You know. So how was the trial with AWK? Someone want to say a few words, what he was trying to do it?
Yeah, I actually had a question. If I have multiple if statements, so let's say I want everything but the first row up to whatever, the 10th, how can I have multiple, like an and? If larger than n larger than 1 and smaller than 10?
Yes, so that one is number of row larger than 1 and
2 ampersands.
number of row, number of row less than 10. Try should work. We can try immediately. Print.
Yeah, that looks good.
Yeah, so is rather than you have also the or with the pipe. And this one should less than, why is giving to you the full?
Oh, actually,
Because is larger than 1 is everything, you know. It's everything, including bigger than 10.
yes,
Because in an
yes,
all
it's everything.
condition, it
Yes,
is
yes, yes.
everything. So, so in this case, the end is what you need. Okay. Okay, perfect. So you can use the AWK for we saw before. I know. Let's do it this one. That is a bit complex in the sense. You know, you can integrate bash variable inside AWK. So, for example, over here, my bash variable is I. Okay. So if I have I that is going from 1 to 4, and this one identify in my AWK identify the column. So if I define a variable, bash variable in bash, then the only way to transfer inside AWK is with the option V that stay for variable. And then I say, okay, my bash variable, my AWK variable is going to be equal to my bash variable. So that's why over here, the dollar identify, we make bigger. The dollar identify the bash variable, rather this one is identify the AWK variable. And now we can say print $I. So over here, I'm not nothing else that, you know, printing one column under the other one. Click, 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 because it's going to do, and of course, I'm reading the file 4 times. So it's going to be print column number 1, room is printing everything. Then the second time, column number 2. Third time, column number 3, and then column number 4. So it's printing one behind the other. It's not a very common operation, but what is very common is importing the variable, the bash variable inside AWK. Due to that another programming language, you need to import this variable. There are also ways to importing a bash variable inside Python, a bash variable inside R. And also in this case, AWK is a new language, so you need to transfer this variable, bash variable inside AWK, and you do with this one -v, okay? It's not very common, but you know, if you start to build up a for loop in bash where you have do it some operation inside AWK, you need to import in this variable inside. And remember to always define, because if you don't define, he doesn't know what is I, because you need to define, you need to importing the variable. Every time that you change a programming language, you need to do importing the variable, you need to do the importing. And sometimes you even need the exporting, we will see later on. Anyway, this is how you do the importing. We will see some other example. Then you can do the typical operation that you do between mathematical operation in columns, you know, logarithm of $5. You can do string manipulation. Okay, so for example, over here you have the nuts, you know, the nuts is 5-digit, but you are interested in only the 4-digit. So you can say, okay, sub str, you remember sub string, str is the string. So a sub, a little element of $1, so that is this one, go from 1 to 4. So going from this one to the 4th element. And so it's going to print this one over here. Okay. Then the if condition that we say $3 bigger to print, we say before, this is the other way to having an index, the one that I mentioned before. And in particular, you have adding the index, okay, but you can index 1, 2, 3, but you also want to add in the full word index. So you say if number of row bigger than 1, equal to 1, print index, and then everything. So it's going to be this one. Okay. And then print whatever is else. So this is the way how to build up an index. This one for getting the maximum value of in a defined column. This one is also very common to do this kind of operation. So, okay, again, number of row bigger than 1, you skip the header, and then you say if $4 is bigger than max, then max become $4. So in the next loop, if it's find again in the cascade mode, they find again the $4 is bigger than max, is going to be max equal to $4. So, and in the end, is going to print max. So these are very simple example that you can use it and easy to find search the maximum value with AWK in our column. Okay, so very straightforward. Of course, then it's becoming more complicated. If you say maximum column number 2, and also the maximum in number 4. So over there is where you have to become a bit more complex. So you have to do several if conditions, but probably in that moment you go inside Python because your data set is becoming already smaller. Okay. This one is the sum that we saw it before. This one, the end condition that we also see with the Martin question. Okay, so it's an if condition. For $3, it was equal 0.7, was the months, but also only 2005, and you get the sum only in July, only in 2005, you get the sum directly. Okay. Yeah, there are also some query operation and some query operation. So for example, this one is how to get. So you can do some kind of operation. So for example, if you want to count, this one is the size of a file, you know, so you want to count how many the overall. Okay, I don't have this one, but let's do an input. Okay, so over here, of course, you can do some operation. This one, they were the size of the file. So this one is 1, 2, 3, 4, and 5. So of course, you can do over here, you can do the sum of this one, and you can get the value in bytes. Okay, so of course, you can do directly this operation directly with a file, size in this case. So quite a lot. And another one very, very beautiful is this one. If you have a very big file, let's say 10 giga file, and you want to split it in several files of 1,000 row, actually, no, this one is different. Yeah, no, this is correct. You want to split the file in 1,000 row, in 1,000, each file 1,000. So you do this operation. Okay, and this one is allow you to create. Let's do it in using this file. So I enter in this folder. Okay, and you can do, you know, AWK. Perfect. Now you will have many block file. Let's see if it's working correct. Yeah, you will have many block file, and I call it block file because, you know, each single file is a block of 1,000 line, WC, and each one will have 1,000 row. Okay, we'll have 1,000 row apart the last one that was the remaining one. Okay, so this is very useful to to do later on multi-core operation in each one of these files. So even if you have a large file, 10 gigabytes of file, then with this one, you can split it, and then you can do each file one operation. Okay, so this is very handy. I use it several times.
So is the percent symbol, sorry, is the percent symbol then the modulus? Like it checks if the number of row divided by 1,000 is equal to 1, and that's how you get every
Yes,
1,000
perfect.
lines?
Perfect. Yeah, that one is the meaning of that one. It's checking. It's checking if every 1,000 line. Yes. Then there is another one. I didn't that you can even sampling. Maybe it's down here. You can even say, okay, from a large file, making random sampling. Okay, of selecting one random. Yeah, you can do, actually you can do it the two command with AWK, but also there is another shuffle, I think is the command that you can select 1,000 or 1,000, whatever you want to select row in a sampling file. That one is very useful when you, especially when you are building up a model and you don't want to work with a full file, but you want to just a sample to have a fast iteration, even before to enter in R. You know, R is very run consuming, so you are not going to do the sampling inside R, and then the memory is already filled up with the large file. You do the sampling outside in AWK or in the shuffle. I will ping. I will take out the command, and then you use this small file that is a random sampling inside R. You build up your script for R, and then before you just test it. Okay, rather than 1,000, do 20,000. And you test it again. And then you say, okay, I have the weekend free. Let's run it the full operation. And you do it with the full file, okay? Or the same if you do it the block file. You can test it even with one file, and then you can do it with all the file, okay? So this is very handy. I use it several times. This one is for, actually, as soon you request, Alex, this is the question that you were asking me. It was already here. So this is the, you can build up a file. So let's build up a file in a, yes. So if we build up a file like this, okay, so over here I have my CSV file that has the typical header number and some number, header and the some number. And then you build up a, say, okay, you build up a for loop inside, okay? And the for loop inside the AWK, that's why it's becoming, because as I mentioned before, you have the automatical procedure to go down. So you don't need any for loop to go down, but you need a for loop inside to the column to move. And you say, okay, for loop from column 1 to up to the end and up to the number of field. If the dollar the dollar, so this column is equal to something, then print that column, okay? Else just print something else. So this one, you know, is in this particular case is going to check and print only column B. So this one, column B, so the third one, and the total. Of course, it's going to read the file twice, okay? So probably there are going to be also way to do it only once, but this is how you do it in if you want to print just one specific header. So as you can see, it starts to become a bit fancy. So sometimes if you really need, you spend a bit of time and you build up your AWK line. If not, just whatever I present over here, print the $1, $2, some if condition, your file becomes smaller, and then you enter in R or in Python, okay? So this is the way to use it. The one that I was searching before. Yeah, for example, this one is also for some quantile number. Okay, so there are plenty of example over here you can go through, but these are the most important one that I quite often use it. You know, I would say even this one, I start to not use it anymore, but before, yes, many times. Okay, and the beauty again is something that you can apply to several data sets without any constraints. Yeah. So anyone is thinking how to apply, he has a big data set to handling with this kind of operation and you want to try. Not now, but he said, yes, I'm trying. I was thinking to download this data set and use it for, maybe he can say something. We have 20 persons, so let's see who is not willing to do it now, but thinking to do it, at least.
Yeah, I can give it a try. I've got a large data set that maybe sometime over the weekend.
Okay, perfect. So can you describe the data set if you remember?
Thereabouts. So it's a series of, it's a landscape data set that has the NDVI and the time, the month and year that certain plots of land were burnt in the southeastern United States. And I think it's around 7 gigabytes-ish.
Yeah, perfect. So this is a good size that start to become, you know, a bit complex to do it in R, because as soon you, especially if you work in the laptop, your laptop is maybe 30, if you're lucky, 30 giga. But if you are unlimited 8 giga, actually with a virtual machine 8 giga and start to dealing with these 6 giga, you're going to stop everything. Okay, yeah. So rather in R, rather if you do it in the virtual machine, you can do it with Bash without filling up the RAM. Okay, very good. So you can prepare this example for next lecture. And in this line, I want to bring your attention to this other example that is in the syllabus. So if you go back to the syllabus and you click over here, explain, GSIM text file, okay? This is a wonderful data set because for this kind of example operation. So you can, I posted in Mattermost to download in advance. If you didn't do it, you can do it, but maybe your internet connection can be slowing down. So you can just follow up and see the data set, because then you can work with this data set. In particular, this data set is coming from these two publications. That is a database for flow rate in streams at global level. Okay, there are two very well done from a group over here in Europe, in Switzerland, Germany. Two data set, two publications where they explain very well the data set. So feel free to go deep if you want. If not, just download it and start to play. You know. So if you play, okay, if you download this one, I already downloaded. So the best way is to put under CD data, media. So inside here, you can create a folder, and this is how you can create the folder here directly. Okay, make dir, you create the folder, you enter in that folder, and you download it. wget, as I mentioned the other time, is also stay for webget. Okay, and you can download whatever you want. The manual is enormous. Okay, and also sometimes, especially because I don't know how to build up web very well. So it always is a bit tricky to understand how to build up, how to make the option over here in order to be able to download the right file. I mean, in the right way, let's say. So this one is quite easy because you don't need any fancy option, and you download directly the zip file. Just for your understanding, if you do how you do it. So if you go over here, this is how I build up usually the wget line. So every time that you go in one line, so you go to this data set and you want to download it. I need to enter maybe. So usually the same line, let me paste the full line. Usually the same line that you copy, that is given to you when you click in one file, that is starting to download the paste and go, you go, and this one, is starting to download it. And you will see this line over here, and this is the line that you, oops, sorry. So I quite often I do it manually, okay, in the web operation. And then as soon as I see that it's downloading, I stop it, or you do right click, copy download link, okay, and then I paste it in my script. This is how I usually do it, how to get the copy link from the download. So I started the downloading link manually, and then I do copy the download link and I paste in my script. In this way, I know that is where it's coming from. I don't do it manually and finish up manually. I start manually, I copy paste, and then I do the wget. In this way, also, if I need to redo it, is already there, the link. Okay. Okay, so if we go back to our example, so this data set, you can enter, you download it, you unzip it. This is the unzip command that you can do it, and you enter it inside to this folder. Okay. So CD, because I need also to enter here, GSM zip. Okay. So now you can see, look, even there are so many the file that even in taking time to download, to list the file. So immediately WC-L, now you should know, and you can see that there are 30 something, 35,000, yeah, 30,000 data set, okay? These are very, very well structured. So I didn't find any mistake. I mean, mistake from a file, from a structured file, then it can be some error in the value of that are inside. But all of them, they are text file. Even if this is a string is an extension, everything that is over here is identify a format, but is not, is just a label of the file. Okay, so in this case, the mon identify month, but you can immediately open with is a text file. So you can open with the command that I mentioned to you. So over here, you can see immediately that is, you have the text file with all the information of the station, the lat long information, and then you have the dates. Okay, be careful that you have the value of the flow discharge in this particular station at this time, but sometimes you can have NA. Okay, so only in some specific years the station start to recording, and also you can have NA in the middle, even even here. So what does mean that the station was working until September 30 and then was stopped, we don't know for any reason, and then was starting again in the 71, okay, November 71. So this is all the different file, they can have a different length. So immediately another test that you can do it, okay, let me count, are these file all the same in terms of length? So you can do immediately like this. Let me do it only for one country. Each one is identified WZV. I don't know, maybe, I don't know which is the country with this one. You can do immediately WC dash L, and you can see, okay, each one is a different length. Okay, so this one is very easy to do it. Each one has a different length. We know the header, but they are not each one from the beginning up to the, they are not from the 60 to 2000. Someone can be shorter from the 80 to 90. Another one can be from 81 to 97. So they can be a different length, okay? So these are the kind of testing that you can do it. And of course, you can do it for all the, you can do it for all the count, 30,000. So as you can see, start to become big, okay? Start to become quite intense to do it. You can see, okay, let's concentrate immediately. You say, let me see the United States, and let's create a TXT file only for United States. So we know that United States is starting with this one, US. I do US because it's quite large data set. So we have, how many we have immediately? You count WC dash L. You say, okay, 9,000, quite big. Okay. So let me get in all these months the world latitude, because if you remember, when I was searching, when I was testing the first one more, you can see that this one has the word latitude. And we know how to get this one latitude, how we do it. We do it with grep, okay? We grep latitude, and we are interested in what? In only the fourth column. So 1, 2, 3, also this one is counted as a column, and then 4. And you do grep, print, number 4, and I can see immediately, let me see if there is any missing between latitude and longitude, because if this one is missing, then, so we have 94 information value for latitude, and let's see longitude. For longitude, we have the same. Okay, so we know that each single station for United States has the same information. We can even say, are we getting all the file? Okay, we count also all the file, ls wc-l, we count all the file. Okay, perfect. So we have 94 file, 04 latitude information, 9404 longitude information. Okay, so now let's build up our TXT file, and we do it like the other time. So we do it the same, but this one we were getting, you remember we were getting this one, we paste for the lat long, we do it like this. So one is going to be for the longitude, and the other one is going to be for the latitude. So you paste this line over here. And this one immediately is creating your file that is going to be, oops, is going to be my TXT file. Okay, with lat long information, straight. Okay, so immediately with a few lines, you already have your lat long information. Let's see, does it make sense? So there is this funny, it's very old graphical interface, but I keep using from trying to find new plot, the new. Maybe I don't have it, but we can install it. Yeah, I've installed. Yes, let's do this one. I keep using from time to time because it's very fast. So I don't need, for doing it in R, I use it R for in Python also, sometimes for graphics. But if I'm in the data discover, I use it new plot because I can immediately plot. So my file was this one. I call new plot. Okay. And then I say plot. It was this one. using 1 and 2. I think I need a U. And I need the quotation. And this one is my United States. Okay, so very fast without entering R, you know, plotting, loading the file, and then I of course is not super fancy graphics. I'm not going to create a graphics for, but look, I can see, is Alaska there? Yes, it's over here, and actually there is also a Y. Okay, so this is very super easy operation, and the beauty that you can also use AWK inside here if you have a large file. Okay, you can use new plot, you can sampling with AWK. Let's do it with a, I need to check, but I think it's like this. No. Yeah, so over here is not AWK, but is bash. And I say, okay, get only the first 10 lines, but it's the same. You can do it as in the same way that I use it bash over here, you can use the AWK. Okay. So you can do really, and it's super, super fast. I was plotting billion of row and it was boom. Immediately you plot. There are also the fancy one with the 3D that you can even move a bit like in R. I don't know if I have it here, new plot. No, I don't have any example, but they are very easy to find in internet. You can do fancy graphics, but it's very tedious, and fancy one I do it in R. But for this kind of operation are really easy to do it. Okay. So you can close it. And this one again, to exit, quit. Yes, so you can go back in the same operation. So another operation that you can say, okay, let's count. We have the column mean, and let's count. Do you remember that we were, you know, in each single one, there were some that they have NA, there's some mean. So the second column have NA. Okay, let's count how many they have NA and how many have value. So all this kind of operation, you can do it. You can say, okay, if number of field is bigger than 5 because I want to get rid of all the header. So if I do bigger than 5, I can get only the mean, you know, because these one are more than 5. Okay, you can say bigger than 5, print only number 2. Okay, so immediately I can say, okay, how many I have with with NA, and I can say grep -v date. The -v is because somewhere I have date here. Grep date. Okay, somewhere in this line I have date. So without yeah, with the -v, you skip it if there is any file, any line with a date. Okay, so the total one will be, let's see, I didn't paste this one. Ah, sorry. Okay, so I have I have someone, some of them, the total will be a slight different. Then we can check why. There are 6,000, and then if I do the same, but rather than grabbing the one with the NA, okay, grep with the one with the NA, so I can do it here the same, perfect the same, but grep with NA. So I can see that there are much less, or much less with NA. So I can count immediately how many NA, how many. Yeah, there's slight different. Probably maybe some file was missing when I done. And so on. You can do all this kind of operation. You can count how many observation per date with all this full line by sorting and so on. So you can say, okay, let me count how many observation per day. So you can say how many, if $1, so the mean is bigger than 0, print $1, sort and make the counting. So this is a huge for loop, but it's done in only one line. So you can see that in each single month, you have several observations, okay? So of course, someone will, especially in the beginning of the century, you will have just few observation, very old from last century, from 2 centuries ago, okay? Or you can even do a kind of account of distribution of the mean. If you, especially if you sort it, you know, sometimes even, especially for checking the statistics, so you want to check the distribution, if it's normal distributor and so on, even by, okay, there are statistical techniques, but even, you know, and now you will see, even without the statistic technique, let me do it like this way. You can see that I have, now he's coming. I have many observation with a small number. Now you can see many observation. This is the number of observation, number of mean with a very low value of this charge. So what does it mean? That is skewed to the left. Okay, so you have many observation with a small number, and it's true, you have many river with a small water quantity, and you have very few, very big amount like Nilo or Mississippi, you know. So even immediately you can see that over here you have decreasing. So this is not normal distributed, but is skewed to the left. So you have many high value and low. So even without, you know, do any statistical set, you can say, okay, it's normal, is skewed to the left. So I need to do log transform to work with this data. So this kind of operation that you can do it in a fast way. Okay. So it's very, I really like this data set, not only from the science aspect, but really because it's very well structured. Is done by has been done in MATLAB, but you know, it's when you see, okay, they've been producing very, very well structured data because all of them, they have the same system. When you find this kind of data set, it's very easy to work, you know, because you can, rather if they are data sets that are done a bit manually, let's say, then it's a bit a nightmare, because when, I mean, then what you get is not really what you get a missing. And if you are missing, of course, over here, if they are missing columns, or you know, in the over here, if you no yeah, it was, yes, this one over here. If is is missing one comma somewhere, then of course my code is going to be have a mistake. I mean, I will get an output, but probably is going to be wrong. So always try to double check and do a fast operation to see the structure of your data set, like counting number of line, counting number of field. So if for example, number of field, this one, AWK, this is very, I always do it. Print number of field, capital letter, upper, oops. Okay, you can see that the first row is this one, you know, you have only one row that is this, then another one, then you have 5 over here and so on. And you can see that my header is, is starting from here, 11. 11 because you go here, you count, these are 11 column, 1, 2, 3, 4, 5. So you can start to say, okay, let me see if all the value I have 11 column, or there is something between, okay, there is also 10, so be careful. So you need to search if after the 11, all the value have 11, or if something is missing. Okay, so this one you can see, for example, let's do this example. So over here, let's see how many there are over here. So this one, let's suppose that these are constant, and we want to concentrate our attention in this. Okay, so we do it in this one. So let's do it manually without. So if I do head, I can get the first one. Let's see, a bit more. Let's say 16. Okay, a bit more. Probably 26 is too much. 21. Okay, 21, starting from 22, starting the 22 is already the header. Okay, we are not interested in the header from the 23. Okay, so if I say print everything that is bigger than 23 in AWK, is giving to me only the value for all the file. So immediately, AWK print, sorry, if number of field, number of row equal bigger than 20, we say 23, print everything. Okay, print the number of field. We want to see how many field you have. Sorry, here is the opposite. Okay, so now is 11. Okay, in this one, everything is in 11. We are concentrating everything that was bigger than 23. Okay, now we just do it like this, We do it for all. Let's do it again, United States. Now is printing everything for United States. Okay, so how we can do it?
Unique.
Unique, very well. So unique, okay. Look, there is something that is in some file, there is something that is missing, unique, and actually we do sort and then unique again. Okay, so some file now we need to investigate why. Many actually you can if you do it, you take out this, you do unique -c. You can see that many file they have 11. Okay, many have 5, but some of them have 4. Now we need to investigate which one have 4 and why. Maybe there is something inside one file and we need to search for it. Okay. Actually over here I make a mistake. Here is missing. So yeah, that's why it was not working. Okay, so I have several files sorting. So look, most of them have 11, but some of them have 15. Some of them are 15, number of field 15. I don't know which file. We need to investigate which file have 15. So you go deep in searching this one, why they have 15. Maybe there is some, because I say 23, and actually I think what is happening. So I say bigger than 23, but maybe some are missing the river name. And of course, if it's missing the river name, everything goes up. So is not meaningful anymore. So probably I'm getting in some file, this header is shorter. Okay, so this is how you can investigate the data set. So start to play with this data set or use your data set. I mean, so it's very useful for this kind of operation. And in particular, I build up this little exercise, this compulsory assignment. So this now is compulsory for next weekend and next week. So for the 10th of April, so I give you 1 week, more or less, 6 days. So using this data set, you have to, you have to create for each single file, for each single month, year, you have to create using only United States. In this way, is a bit, it's a bit faster. Only United States, you have to create, for each file of these, all the station, the number of this is the station ID with the lat long information and the value of the mean. Okay. For each one of course, if you have, like Rosie was mentioned, that he has some data set that you want to try, it's the same. I mean, it's fine. Also, another kind of tasking. But if you don't having any file that you want to operate, you can start to use it. For example, Samuel, for you, this data set is in line in your PhD work, so it's good to get familiar with this kind of data set. Or feel free to download something else. Okay.
Yeah. Okay.
Yeah.
Thank you.
Okay. Is it clear, the assignment? Okay. It's for each month, year, one file with all the station for United States. Okay.
Where do we find these assignments again? Sorry.
Yes, just below in the syllabus. So you just go in the same
Okay, it's one of
lecture,
the.
you just go down. So over here you have the lecture that we have been talking so far, and actually there is also the recorded video from last year over here. It's pretty the same, but if you want heard in another way, but it's also here. And over here is the assignment that you have to do it for the 10 of. And once again, if you want to work with your data set, is fine. Just handling a scripting procedure that use AWK and Bash to do some, data summary, data reorganization, data filtering, this kind of, if also, okay, try to do it with more than one file, if not with one file, everything become easy. But also, if you have one big file, is also fine. Is try to split it, working with few files. You can build up some kind of example. Okay. Is it clear? Anyone? Any question in this line? Okay. Samuel, you want to work with this data set, or you are thinking to do some other data set to use it?
Yeah, I might try this. I might try this a little bit.
Okay, perfect. So this one is also good because you have the procedure how to download it. Is you can read. Of course, if you read this, especially this one. Of course, over here I'm working this monthly data set, but there are also other.
Is there a daily data set?
Yes.
Also daily data set on the same website, right?
Actually, I don't know if there are daily. If you want to use daily, feel free to use daily. Let me know where you find it. Over here, there is also some other statistics. So there are other data sets that are here. Monthly homogeneous, yes, is a kind of quality control data set, and this is also a CSV file. So you can use also this one. If you want information, you can read, these two publications, but you can play, you know,
Yeah.
you can play with this kind of data set and figure out something.
Yeah.
Okay,
Okay.
cool. Okay, so it's getting it's shaping a bit why we are learning this. You can already see the meaning and so on, because next lecture we enter inside to the spatial. Let's say we start working with raster and vector environment with GDAL. So is indeed, if you go down, you have already the GDAL command. Okay, so in 2 days. But whatever we have learned, it will be used also inside to these GDAL operation. It's not that are completely independent. Okay. But of course, we work with text file because it's easier to explain this kind of syntax. So we will navigate inside to the GDAL, and we will spend 2 days in GDAL, 2 full days, because I want to go deep, not only in the command, but also in the how to read carefully the GeoTIFF and the different kind of data set and option inside of the GDAL, the GeoTIFF and so on. So we will go deep in this kind of information. And once again, feel free to start to operate with your data set, to start operating. And every morning, as you can see, as you see today, we will do a round table in asking what you have done and which kind of data set you were manipulating. So feel free to talk for 2-3 minutes in showing what you have done also, because it's also a learning phase also for the other students, also for me. Sometimes I discover something that I didn't know. Okay. Okay, for the people without video, anyone is alive over there?
Hello, Giuseppe.
Yes.
Yes. I don't know if you mentioned it, but I'm just wondering, just want to ask that, just wondering that if I have a bunch of columns that I want to perform an operation on with AWK, is there like a shortcut to say maybe something like dollar column one, then column $1, then maybe a column, and then say 10 to indicate from columns 1 to 10, I want to print those columns rather than saying $1, $2, $3, then up to $10.
Okay. I think I understood what you mean. Yes and no. So let me. So Olatin was asking, you know, is still sharing. Yes. So if I have because I changed 1 second. I was in time series. Month. So Alatin was asking if there is a way to especially this file that can be, or can be even longer, if there is a way, if I want to $4, $5, there are some tricks, but sometimes it's much faster than typing, than not. I will show a few of them. Okay, so number 4 is can print this one. So if you want to, there is one that is I quite often do it. If you want to not print column number 1, you do like this, and then you do $0. Okay. So this one is going to, let me do like this. In this way, you understand what I'm doing. So if I do it, this one. Okay, so over here you can see that over here I have the asterisk. Okay, let's suppose they want to get no asterisk, the pound. I want to get rid of this column over here. So what I can do I can do $1 is equal to nothing. But be careful about this one, because then over here you have a space. Okay, so there is another command that is called seed, that is also another one, is another program for pattern, text pattern recognition and substitution. I never remember the syntax, but anyway, you can do it in some way that you can say, okay, if you have space, like two space, starting with, and I don't remember the syntax, but should be something like this, then we can say, starting with two space, don't put anything. Okay, and then, okay, maybe it's wrong, this one, but maybe it's correct, but it should be something like this. Now I get syntax error. And then you can remove these two spaces. Anyway, what I want to say that every time that you delete one column, you are going to get a space over here. So this is an easy way to remove some column. Then if you need to print, you can do it also a for loop, like I was saying, and then do the printf, but it's getting a bit complex. So it was something like this one. No, sorry.
Okay, like applying a condition to the NF.
Yes, it should be something like this with the printf, but it's a bit, you know, it's more complex writing than not to write 1, 2, 3, 4 times sometimes, and then using the printf condition. You do 4 column 1, 2, 3, and then you do and then over here you need the printf condition with the for loop, because if not you go to the other line. I don't think you do print. If you do print $call, you are going to print here image. Yeah, you need a printf, so it's getting a bit printf, and then you need the percentage string, and then space, comma, columns. Yeah, so this one is more or less what you want, more or less. So with an internal for loop, you can get, you can print all the line without specifying $1, $2, $3. But it's becoming a bit complex actually, because then you have to do in the ending line. So quite often I just printed 1, 2, 3, 4, 5, you know, because if not, you need to work a lot with this printf that sometimes is not so straight to do it. I think this was the question, no?
Yeah, looks like there's no easy way to do that.
Perfect, yeah.
All right, thank you.
Welcome. Okay. Yeah, any other question in this line?
Sorry, I'll ask one another question.
Alex,
Sometimes you print the results of your operations right directly, like in the last example, but sometimes we need to put it under this AND clause, like when you put AND and then print works only after the AND. What is the difference between these two cases, and when exactly we need to put this print only after this AND?
You mean the end, this one that we show in AWK? This is the one, this one?
Yes, exactly.
Perfect. So once again, this one is done whenever, you know, is in the end of the reading of the file. So in this case, we were doing the sum. Okay. So let's do the same example over here. let me go again in this directory. Is easy to. No, possible. Yes, this one. Okay, so if I don't let's do like this. That is easy to. If I do like this, print sum. Okay. Now it's one parenthesis should be this.
I tried this, it doesn't
Perfect.
work.
So what is doing this one? Is doing the computation, and during the reading of the file is printing the sum. So in other words, is nothing else that now this one is becoming a very
cumulative
large
sum.
number. But if you go in the beginning, you do more, you can see that it's growing because it's printing the sum of each single file, okay, of each single line. So this one is increasing. You can see that it's increasing, okay. After a while, it's becoming too large, too huge. So it's getting these this scientific number notation. So if you want, in this case, you can use the printf to transform the syntax in not in a scientific notation, but in a real number. So this one is going to growing, okay? So what is happening that you are not interested in the growing row by row, but you are interested in only the last number, okay? So in this case, you can go back and you can see that this operation only when you are finish up the line, please printf with the value of sum. So the value of sum is going to be what? The last number in the cascade mode. Okay.
Yes,
always
yes,
remember.
yes. Thank you. It's understood now. Yeah.
Perfect. Okay. So again, the beginning is before to read the file. Then you have the action during the reading of the file, and you can say this operation sum, or you can say column 1 times column 2. And then in the end, you can add in something else. Due to that this one is a variable that is changing in the cascade mode, in the end, you are going to print this one. So this value, now you can see that is a quite large value. Is it correct or not? Sometime in the beginning, I was even loading the file in Excel and checking if my operation was correct. Okay, now I know that it's correct and I don't do it anymore. But feel free in the beginning to, or even in R, you know, even in R, you can test it in R if your few line or AWK are correct. Okay, but usually if you maintain very simple, one line should be straight, you know. If you start to build up scripting procedure quite big, then AWK, but nowadays there is no need, you know, just keep it very simple and then enter in R in Python, okay? Very good. Okay, any other question in this line?
I had another question. It's on the same
Yes,
page in cell 15, I think, if you scroll down.
Yeah.
It's this splitting a file into new files each 1,000.
The block file.
Yeah.
Correct?
Oh, it's further up. It's further up. It's block 15.
50. Yes.
Yes.
Perfect.
Could you explain the syntax? I think the problem is again with this first part, because the way I would read it, it's like if the modulus of the row number is equal to 1, then writes it into this text file. But what it actually does is it puts all the last 1,000 lines into a text file, not just line 1,001. Right? So
No, is bringing the every 1,000 line is bringing the one block file.
But but block file is just the name, right? So we make a variable called block file 1,
Perfect.
block file 2, block file 3.
Perfect. Yeah.
And then
in each one of these is putting 1,000 line.
But why is it 1,000 lines? Like, isn't this, if the number of rows, if the modulus of number of rows is equal to 1, take this line and save it. How does it know to use all the 1,000 lines before that too?
And
Because for that, the modulus is like, whatever, 50 and 51
actually,
and 52.
once I was testing, even if you put, because this one, I'm in the right directory.
Because it does work. We had a look at the files, and
yeah,
it's
yeah,
not
this
just one line.
Is what he does. I think is in TXT. I remove it. Let me run it again. Okay, so the block file. Now I will have several block file, 1, 2, 3, 4. We can even test. We can get the first one, we can get the first one and should have the first line of our input file, and should be. So this one should be the last one, the first one, so are the same, 0808. Then the last one, it should be the 50 something, maybe. It should be the last file. Actually, we can do it like this. So probably the last one will have less number. So the 54 should have the last, so the tail should have the tail of our. Perfect. So this one is the last file. So every 1,000 line, it make a new file. Every 1,000 line, you make a new file. Then, yes. So if this condition is true, number of row is making a new file.
But I thought
the syntax is not really easy.
Yeah, because I thought it's like cascading, right? And then it would just write one line, but it actually does remember the last 999 lines as well, right? Because
because it's already writing.
Oh, okay.
It's already writing. Now it's so fast. As soon as you read one line, it read and write. Then it goes to 1001, and then this one change, become block 2. Okay, so this is how he does it.
Yeah, no, I understand that, but then so the print without anything else is just like, oh sorry, print 2x, right, is writing whatever is in print 2x to the file called x, which is block file.
Perfect. So these x change every 1,000 line.
Yes. Yeah.
So every line is writing to block 1 second until the 1,000, then become 1,001, write to the second one, and so on. Okay.
But so if we use the other syntax where it's not outside the curly parentheses, but we actually write if.
It should work the same. Yeah, should work the same.
But does it though? I thought it's.
Why
does it? I have to experiment with it. Maybe I have further questions next week. Yeah.
I did so many tries. I also when I was learning, I try, because also the syntax sometimes can change. There is the other one, sampling every 1,000 line. There is another one, another syntax that I didn't paste, but easy. If I want a value every 1,000 line, for example, there is another way to do it. I think it was like this, and you just print. Let me see. Yeah, so probably this one is print every 1,000 line. Or we can check like this. And so let's see now if this value we have at and dash. Look, there is this one, dash A and dash B. You can print before and after. No, this one. No, I make a mistake. So let's do 4, and then we do tail. So now this value should be in this area, 0613. Yeah, this one. So this one is the number of row, and actually we can even write like this: yes, AWK print the number of row. Yes. So 1000. Okay, 1001. Yes, 06. Okay, because we have the header in the first one. Okay. So this one is for sampling every 1000 line. Actually, it's different between these, and then if you put 0 here, you get something else. If I remember, you get a 106.
Yeah, one above. Yeah.
I think so. It should be, yes, this one. So always play a bit to understand because you don't get syntax error, but then is what you want or not. You know.
Yeah. So this line now prints every 1000th line, right?
Every 1000 line, yeah.
So okay.
And this is also very good for making a small file to start working, especially if it's very big. Or there is the other one, shuffle, random line from file. I think is shuffle. I used it a few weeks ago. Yeah, shuffle. Yeah, so this one, for example, is, I want to, from this file, I want 10 random line. This is also very useful. And every time it's changing. Actually, no. Every time every time it's changing. Okay, so this is also extremely useful. Shuffle, yeah. And you can do it also in WK because there is the command rand. I think is a capital letter. Yeah, you have to check. I don't. It was something rand or maybe not capital. Yeah, this one. Every time you're printing one number, one random number, then you can use that one to sort it randomly, for example.
Mm-hmm.
You can print as another column, and then you can do, sorting, and then get the first 10. It's the same concept. Okay. Okay, Fenchao, what do you think?
Yeah, I think I still need to try more than get familiar with this.
Yeah, so this is the
comments.
trick. Keep trying. This data set is quite huge, so you need to do a lot of testing before to get what you want, let's say. Okay. Any other question from the others? Anyone is alive or not?
Giuseppe, is it possible to maybe talk with you 5 minutes later after class?
Of course. Yeah.
Thank you.
Yes. Also, in this contest, feel free to ping me for some advice in some specific field, and also Lonzu, the other guys, the other teacher that was presenting, the bold guy also, he's also very open to mathematical and statistical question framework, and Turek is strongly. So feel free to mail him. Actually, I think he's already in the Mattermost. Okay. So any other question from the not video people? If not, we can